Hello there, I am Praveen. Hope you all are doing good. So this is the solution that I built for YoYo Test App. I have already started it, it's running. Let me show the UI first, I mean the running application, and then I'll go through the code base. So this is just loaded page. So the moment I click on this, uh, test starts. These are the athletes loaded from server API, the fake database, I mean fake data in memory kind of things. So the moment I click this, you see the shuttle starts and then timer starting and everything. Progress bar is here. Yeah, yeah. So this is running right now. The moment coach wants to warn a warn an athlete, he can click on warn button. That means he cannot warn him again. So only once he can be warned. The next time he does the mistake, he is out of the test. For example, he is out now. I mean, he is doing a mistake. So the recently completed successful level and then shuttle is being applied to him as a result. But then in case coach wants to edit that, he can edit anyways. Yeah. And this is recently completed total distance. This is not the distance of the current ongoing shuttle. This is earlier shuttle's distance. Yeah. So the moment all uh, athletes are out of this test, it would be completed, like test is completed, and these are the results. Of course coach can edit the results. This is how it is. And let me run one more time by just reducing the number of all these tests in the JSON so that we see few more use cases, and then we'll go back to the code base. Let's just keep 3 of these for testing. I'm just loading it again. By the way, this is a solution built with the ASP.NET Core, Blazor, aspnet hosting, so that aspnet server can host the client app as well, which is built and then applied to the server. The shared project is very small class library which has only 2 models in it, which is being shared across these 2 other projects. These are just plain old CLR objects. Yeah, I think application is started now. Yeah, so let's see with 3 uh, shuttles, even the percentage of the progress also we can see right now, because it is very less. We can see so the moment it is crossing one level, we get some percentage. Yeah, this is out of 3, 1 is completed, so 33% is over. So let's wait not to stop all the athletes here, so that automatically the application would stop all the athletes by giving the result, which is the last shuttle number. So let me warn him. See, his result is 9-1, because the 11-1 is current ongoing shuttle. Six more seconds. Now it is 66.6. Yeah. See, now test has closed. I mean, the application has closed or stopped all other athletes who were actually running till the end of the test. So they got the maximum result, which is 11. Others, as and when the coach stops them, they have the results. Test is completed state now. That's it about the user interface so far. Let's look into the details. How did I build the code? As we just saw, this is just having two model classes, athlete and rating. The client is actual code that is UI related. It has only one page, uh, which is a Blazor page mapped to the root URL of the server, root component, I would say. So this actually loads athletes from the server. The moment this page is loaded, athletes would be null or empty. So the API call, which is the code behind file or the page view model, on initialization of the page, it takes data from server. The moment athletes are ready, we see the rest of the page, actual page. In fact, yeah, this is built with the semantic UI, a component library or a framework, which I am comfortable with, just to keep the user interface as near to the UX UI design that I got. So I thought of using it. Little bit of customized CSS. Yeah, so let's see about this HTML first. I mean the Blazor page. It has some dynamic content like enabling, disabling few user interface elements based on the app state or user behavior, with the help of state variables or application state variables defined in the view model class, which is index razor CS, which is a partial class. Of course, these two are one and the same in the runtime, so that's why it's a partial class. We have progress bar here, few information as and when the current shuttle changes, and then based on the state, like what is the next, I mean how in how many seconds the next shuttle starts, something like that. And then we have a button which is displayed the moment the test is completed. Of course, it is fake button, does nothing right now, just to keep the application simple. Yeah, so the list of athletes are being displayed here, with again some kind of dynamic information based on the athletes data. Few buttons, select, all these components are like enabled, disabled, hidden, something like that. And then the athlete ID and the name of the athlete is always displayed, of course. So, and few event handlers are associated in the UI here from here. So these are the methods defined or declared in the code behind file, which is view model for this view or component. Yeah. So now let's see view model class. So it is depending on HTTP client because it has to get data from the server, like ratings, JSON, and also a list of athletes. This is being injected here. And then app state, I have few variables like timer, all those things, like set of Boolean properties to represent the state of the application, time lapse so far, few labels, counters, so on. That is basically the app state region that I have. If you see the initialization, it loads data from HTTP server, I mean the REST API server app. The moment user clicks start button or play button, application state changes to started, and then I have to run the shuttles. At the same time, I have to start a timer which is initialized, and then event is associated in the constructor itself, but then it is not started until start button is clicked. So timer again calls internally for each second the same method. That's what once the timer is elapsing every 1 second, it is being called. This method is called. Yep. So let's see what is there in run shuttles now. For each second, I have a few, of course, I have a few util custom extensions, which are actually to convert uh, integer to string, like the number of seconds to user-friendly text or string, something like that. So every time the counter increases, I have to convert it as a string so that I render it in the UI. Time lapsed so far. And then for the rating data that is retrieved, the JSON values are being iterated if the start time is matching with the current counter, the current seconds, and then I consider it as a current shuttle. If the index is not 0, then the previous shuttle in the array is collected in the variable called previous shuttle, and also total distance ran so far is based on the previous shuttle's accumulated distance. Just to render the progress bar, I'm just calculating a percentage based on the number of elements in the rating data. Get the percentage of progress. Next shuttle countdown. So we need to also identify in how many next seconds the further shuttle is going to be started. For that, there is a method here which is actually calculating time again and then setting a counter down. So cumulative time so far, and then starting time. If we reduce that, we get actual time that we need to wait for the upcoming rating, basically. So we should set that, and then if the time lapse so far the number of seconds lapse so far is matching with the last record in the JSON, the rating, that means it is already completed. So I have to stop all athletes which are not stopped, and then I should set the total distance to current shuttle's accumulated distance, because no more shuttles, so current shuttle is the last shuttle. And then it's like this is for letting the Blazor framework know that there are some UI, state changes, so that UI would refresh by itself. In case if it is not matching, I have to count down and also notify the UI engine, Blazor engine, for the state changes. Count down and then counter up. Yeah, these two things. The countdown is basically checking if the counter is already decreased or not. Like, yeah, if it is already less than or equal to 0, then I have to make the next shuttle in 0 seconds and then return it. Otherwise, I have to count down it. Yeah, that's about running the shuttles. Upon clicking start button, it internally calls stop athlete as well. Of course, coach can also stop the athletes. That is also calling the same method, but then if the coach is stopping the shuttle, it would take another boolean property called by coach or not, like default property value, default parameter value is false. That's why the earlier caller, which is system or application call to stop particular athlete who is already running, who is not stopped so far, is by the system itself, not by the coach. So the default parameter value is false. I have to mark the athlete as stop. Rating should be if like based on the coach, who is stopping it. In case if application is stopping the current shuttle's value should be considered for his rating computation. Otherwise, the previous successful ran, because the coach has just stopped him in the ongoing shuttle. That means earlier shuttle was successfully completed by him. Yeah. Yeah, that's it. In case if I didn't find rating, it is empty. Yeah, so I have to send the information to server such that it is persisted. Right now it is just fake API. It receives and then sends the same athlete back. If there are no more uh, athletes who are running, I have to uh, make the application stop, right? Like that is the point here. So in case if uh, there is one more athlete or few more athletes running, I just skip further code from here, like exit from here. In case if there is no athlete who is running, I have to mark application percentage completion percentage as 100, stop the timer, and then change the variable is completed to true. Notify the Blazor engine for state changes. Yeah. So this stop athlete is internally called by the uh, uh, run shuttles method only at one point of time, because when the time lapse so far is equivalent to the cumulative time of the last rating in the JSON, we have to mark all athletes stopped and then stop the application itself. That is application level or systematic call. Even coach can stop an individual athlete in case if he would like to stop him based on the number of mistakes that he does. Like for example, warning, in case if he is already warned, he can stop him. Only one warning is allowed as per the requirements. So this warn and then stop, these two are being called by the user interface buttons by coach. When it is called, the current particular athlete is marked as warned and then posted to the API so that it is persisted somehow. And also for stopping. Stopping similarly, but in this case, this is by coach true. That means it is deliberately uh, called by the coach. So we should only consider previous shuttle for his level and result computation. Otherwise, it is also does the same thing. Either coach stops the athlete or systematic stopping, whatever it is. About this is about these two. Yeah, I think I have covered this already. So this is for the drop down basically, and yeah, let's go to the API code and see what is there. I mean the server side code, which is basically having three layers like API layer, service, and then repository. Repository is here basically in memory, which is having in memory collection or enumerable athletes initialized when the repository component or service in the DI container is instantiated, something like that. This is some kind of fake data. Get all athletes, get athlete by ID, update athlete. These are like repository calls. Typically, it would be to any kind of data source or database. The service itself is actually does nothing other than depending on the repository and then doing some business logic here. In case if the athlete is being warned, athlete is marked as warned and then it is updated to the data store. While saving the result, he has to be stopped and then set results like what is the level he crossed, shuttle he crossed, something like that, and then update. So from here, repository calls are same. Business logic is there in the service layer. Yep. So these two are actually registered in the IOC container service registry like this. So I'm not registering these as singleton beans just for the simplicity. Ideally, these would be like singleton beans in case if we use any persistent database. Yeah, I think that's it about the code. Hope you like it. Looking forward to listen your feedback. Thank you. Goodbye.